Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life. Please take a moment to like and subscribe. It really helps.
Today, we've got a stack of sources on a NASA mission that, honestly, is anything but typical. It's a story about a mission that was kicked down, rejected, delayed, and somehow just refused to die.
It really is an incredible story of resilience, and often accidental resilience at that. We're talking about the ESCAPADE mission.
ESCAPADE, that's the Escape and Plasma Acceleration and Dynamics Explorers.
A bit of a mouthful, but the science behind it is just fundamental.
Right. And our sources all point to this one big question. Mars used to have a thick atmosphere, it had flowing water. Now it's this cold, dry, almost airless world. So the question is, what happened?
Exactly. And ESCAPADE is going there to basically perform forensic science on a planetary scale. It's using these two small spacecraft to figure out how the solar wind stripped that atmosphere away over billions of years.
So it's a history mystery.
It is, but it's also, and you see this in the reporting, being called a trailblazer. It's not just about the science, it's about a whole new way of doing deep space missions for NASA.
More cost-effective, you mean?
Way more cost-effective. But it's also pioneering a path for, believe it or not, future human exploration. It's a fascinating double act.
And before we even get into all that, we have to talk about the backstory. The sources call it the Great Escape mission. It needed, 9 lives just to get off the ground?
At least 9. Yeah, the story of how it even got approved is just wild.
Okay, let's start there. The mission that refused to die.
Well, to start with, the whole concept was initially rejected by NASA. It was a non-starter.
So how to get a second chance?
Pure happenstance. In 2018, there was a federal government shutdown, and that delayed NASA's selection process for these small missions. And by the time they got around to finishing their evaluations, months later, the main competitor, a Venus orbiter, had run out of time. Its launch window was just too tight.
So it was disqualified.
It was disqualified. And ESCAPADE got the green light. It literally owes its existence to a government shutdown. It's incredible.
That is just unbelievable luck. But then it immediately hit another wall, right? It lost its ride.
Yep. It was supposed to be a secondary payload, just hitching a ride on the big Psyche mission. But then SpaceX moved Psyche's launch date up.
And they used a more powerful rocket.
Exactly. So Psyche no longer needed a gravity-assist slingshot past Mars, which is what ESCAPADE was counting on. So poof, the mission was kicked off. No ride to Mars.
This is the kind of thing that just kills a mission, especially a small one.
Normally, yes. But this is where the whole structure of the mission comes in. It's part of NASA's SimpleX program.
Small, innovative missions for planetary exploration.
Right. The whole point is to do big science on a tiny budget using commercial tech wherever you can, and the budget numbers here are they're staggering.
Okay, so lay it on us. What's the total cost?
The entire mission development launch, the whole 9 yards, is $94.2 million.
$94 million. For a Mars mission. How does that compare to, say, the last one?
Well, the last orbiter to study Mars's atmosphere was AVIN back in 2013. That cost almost $600 million.
$600 million. So this is, about a sixth of the price?
A sixth of the price. For 2 spacecraft, not 1. They're called Blue and Gold, the Berkeley school colors, and they're each about the size of a mini fridge.
So hold on. How do you cut the cost that much? What's the secret? Is it just, better management, or are they cutting corners on the science?
It's mostly innovation in the process. They didn't cut the science. They cut the time and the bureaucracy. They used commercial, off-the-shelf parts, ACES components wherever they could.
Stuff you just buy.
Basically.
Yeah.
And they partnered with Rocket Lab, who used their standardized small satellite platforms. It just streamlines everything. The whole build was this 3.5-year sprint.
A sprint that ended with them sitting in a garage.
Pretty much. They finished the spacecraft, and then their new ride, Blue Origin's New Glenn rocket, wasn't ready. It was its first ever launch, so the 2 little orbiters just had to go into storage.
But that delay actually ended up saving them money again, right?
It did. Because it was the first launch of this brand new rocket, NASA got a bargain basement price. $20 million for the launch.
$20 million. That's incredible.
Yeah. And the sources all note that the New Glenn rocket is comically oversized for this. It's like using a 747 to deliver a birthday card. But hey, it worked out perfectly for the budget.
So after all that drama, let's talk about the science. Where are they going? We know Mars used to have a global magnetic field, right? Billions of years ago.
That's right. It had a molten churning core, what scientists call a planetary dynamo, that created a magnetic shield, just like Earth's.
But then it cooled down.
The dynamo died, And when the shield failed, the Martian atmosphere was just exposed. It was hit with the full force of the solar wind.
Which is that constant stream of super-fast, high-energy particles coming from the sun.
Exactly, and that's what stripped the atmosphere away. Today, Mars only has these little patches of magnetism left, frozen into rocks in the crust. It deflects some of the solar wind, but it wasn't enough.
And ESCAPADE's job is to map that process, to see it happening in real time.
And this is the really groundbreaking part of the methodology. It's the first time we've ever sent a coordinated dual spacecraft mission to orbit another planet.
Having two of them, blue and gold.
Yeah. Having two identical orbiters finally lets you distinguish between a change that happens over time, did the solar wind suddenly get stronger, and a change that happens in a different place.
I see. So you can tell if something happened everywhere at once or just in one spot?
Precisely. They both carry the same set of instruments, a magnetometer to measure the magnetic fields,
and an electrostatic analyzer. What's that do?
It's essentially a camera for charged particles. It images the electrons and protons, so you can literally see where the solar wind is flowing and where bits of the atmosphere are being carried away.
And then there's a probe for temperature and density. And even a camera built by students, which is pretty cool.
Yeah, from Northern Arizona University. So their science campaign starts in June 2028, and it's split into two phases.
The first one is called the String of Pearls formation.
Right. For 6 months, the two spacecraft will follow each other on the exact same orbit, just minutes apart. They swing in close, about 100 miles out, then way out to over 4,000 miles.
So they're sampling the same bit of space at slightly different times.
Exactly. That tells you how quickly conditions are changing. It's vital for building accurate models.
Okay, and then phase 2.
For the next 5 months, they split up. They go into completely different orbits, one far out, one much closer in.
To measure two different places at the same time.
You got it. Think of it this way. One spacecraft can be out in front of Mars, measuring the solar wind as it comes in, undisturbed.
While the other one is tucked in behind the planet.
Right, watching what happens in the in the magnetotail, where the magnetic field gets stretched out. You get the whole picture at once.
And this all comes back to protecting future astronauts. Right. Understanding the radiation environment is critical if we're ever going to send people there for long periods.
Absolutely. You need these maps to keep people and robots safe. It's fundamental for future exploration.
Okay, so the science is fantastic. The budget is a miracle. But the story of how they're actually getting there might be the most innovative part of the whole mission.
It's an absolutely brilliant piece of orbital mechanics. So like we said, they missed their original launch window. Earth and Mars only line up for a direct, fuel-efficient trip once every 26 months.
So they were facing a huge delay.
You'd think so, but an orbital mechanics expert named Jeffrey Parker came up with this. Just an ingenious new trajectory. They launched in November 2025, but they're not going straight to Mars.
Where are they going?
They're on this big, looping, kidney bean-shaped orbit that goes way out around a spot in space called L2.
Lagrange point 2. That's a point where the sun and Earth's gravity kind of balance out, right? Like a cosmic parking spot.
A very distant parking spot, yeah. And they're just going to loiter out there for a full year, just waiting. Then, in November 2026, the orbit brings them swinging back past Earth. They'll get a gravitational slingshot, fire their engines, and then they head to Mars.
That is incredibly elegant, and it has huge implications.
Massive, because that traditional launch window, the one that only opens for a few weeks every 2 years, that's a huge bottleneck for logistics.
You can't run a colony if you can only send supply ships during a 2-week window every 2 years.
You absolutely can't. This new trajectory changes the whole game.
How so?
By using this L2 loiter orbit, you can now launch from Earth anytime during a window that lasts over a year, instead of just a few weeks.
A whole year, so you could send hundreds of ships.
You could send hundreds or thousands of ships. You can, as the mission lead Rob Lillis put it, sort of queue them all up to head off to Mars.
It basically creates the Mars commute.
It really does. It paves the way for a constant supply chain. It's a purely orbital innovation that solves one of the biggest practical problems of colonizing another planet.
So when you wrap this all up, this deep dive shows a mission that is just. It's remarkable. Remarkable for its resilience, for its incredible cost efficiency, and for this totally new way of using twin spacecraft to solve a huge planetary mystery.
Yeah, and what I find so fascinating is the irony of it all. Here you have a mission that's all about figuring out why Mars is a dead desert planet today.
Right, studying its atmospheric death.
And in doing that, it's simultaneously pioneering the exact logistical pathway that future missions will need to establish a permanent, living human presence there. It's looking into the past to build the road to the future.
That's a powerful way to put it, and it definitely leaves you with a big question to think about. If this new year-long launch window makes it feasible to send constant supply chains to Mars, solving that huge orbital challenge, what do you think the biggest barrier is now? What are the technological or even political hurdles, the non-orbital ones, that will become the hardest to overcome for a self-sustaining Martian colony?
Don't forget to like and subscribe for the next episode on While We Were Distracted.